topic of today is, of course, model-based definition. We want to talk, or I want to talk about the news, but I will probably focus more on the general processes and the potential of MBD. But of course, I will cover the news as well. But first, I can just introduce myself a little bit. My name is Jonas Fransson. I'm working as the head of customer success at PDSVISION. I've been a part of PDSVISION for 10 years now, and have during those years worked closely with our customers and in training and methodology projects. So that's a little bit about myself. I can also mention that we have this series of Creo 8 related webinars. So at the moment we have completed the general overview. We have completed the first deep dive related to core modeling. And now, of course, we're talking about model-based definition and GD&T Advisor as well. And next week, Mikko will talk about the news related to simulation and generative design or topology optimization. So when all of this webinar is completed, we will put them on our homepage, so you will be able to access them as an on-demand webinar. So you can see it again if you want to. And today, I will focus around a couple of questions. So the first thing I want to cover is how model-based definition, or MBD, relates to something we call model-based enterprise. What's the difference between those, and what is hidden inside those acronyms, MBD and MBE. I will talk about why you should implement a model-based definition process and think about this. And I will also introduce a couple of pieces of software that can be used to extend how you are defining your model-based definitions. And of course, there will be a few minutes related to what's actually new in Creo 8 as well. Yeah, so what you can see on the screen now is an example of a model-based definition. So what we basically want to do is to store all the product manufacturing information directly inside the model and get rid of the extra document that we generate traditionally based on our model today. So the drawing itself is not a necessary part when it comes to developing products. I can also mention now that MBD doesn't necessarily mean that we are paperless, so you can still print your definitions and your combined states, so we can have them on paper if required. But one of the things we want to do is to get rid of the drawing and to keep as much information as possible directly on the model. So what I want to say with this picture is that the model-based definition, it's contained inside Creo. So that means that we can generate information needed within Creo Parametric. So we define all the PMI, or product manufacturing information, directly on the model by using combined states. And Creo Parametric is managing all of that, more or less. So you can run an MBD by only using Creo Parametric, but the next step is to manage that data, and that is done within Windchill. So when you have Windchill in place, we can also leverage from the information that we have generated in Creo Parametric and use it in a model-based enterprise. So we can use the information that is born in CAD in order to generate work instructions or illustrations and to communicate with each other and to, pretty much anything, requirements and so on. So a model-based enterprise is more of a concept that wants to use the model-based information as much as possible. So today, I guess that many of you participating on this webinar is already on the model-based enterprise journey. Maybe you haven't defined it like that, but if you, for example, are using Windchill EBOMs or part management, or if you're using Creo Illustrate and that kind of information, then you already started your MBE journey or your digital deployment. The general process for creating MBD information follows this path. So we have a prepare state where we, inside Creo Parametric, make our model ready for MBD. So that means that we need to create something called combined states. We need to make sure that we have a sitemap or a definition of what should be contained where. We need to make sure that the information needed for the downstream consumers is available and so on. So that is managed inside Creo Parametric. We can get some help from additional applications like PDSVISION Creo application and the classification capabilities inside that one. Or we can use, a tool called Smart Update, which is a tool developed by BMW, German company. So I will show this later inside Creo, how I'll do this. When we have prepared and we have a starting position, then we start to define, basically, and enrich the model. And in order to do that, we can use the standard Creo parametric capabilities, of course. We use the Gdt Advisor for geometrical dimensions and tolerances. We can color code if we want to. We can add nodes, symbols, dimensions, and so on. Here we also have some additional pieces of software that can be added. It's not necessary, but they will help you to speed up the process. So those two steps will be the primary focus of today's webinar. But then we also have an extended process, which means that the information that we create should be published. So we have something that can be validated and then in the end consumed by end users. And that is managed inside Windchill traditionally. It's stored in something we call TDP, or Technical Data Package. The out-of-the-box capabilities that comes with Windchill is based on Creo View. So we publish the data to PVSet format and open review it inside Creo View. There is some additional capabilities here as well. So we could, for example, publish to PDF to have a more general format, or publish to HTML format, for example. So while working with MBD, that means that we can have a more streamlined process of how to create products faster and cheaper, and reducing the errors in the end. So this is something that PTC have worked quite hard with, and all new release during the last 10 years have been including or had some parts related to MBD in it. So we are constantly improving this as well, and we've come quite far at this point, definitely. And of course, there's a lot of studies showing that companies that is actually doing this and using the model-based definition approach is generally better, doing things faster, and have increased their revenue and increased their quality. So if we look back a little bit, a few years or more, many of our product development companies were more drawing-centric, which means that they only talked about and used the drawing. Today, I think most of our customers that we are working with is model-centric. So we have the model that is used to generate a drawing, and the drawing is more or less defining key characteristics. So we don't have fully defined the drawing. So the next step for many of you is to start leveraging the model-based definition approach in order to maximize the processes. And even inside this this track, we have a crawl, walk, and run strategy. So you don't need to do everything at once. You can start small, start in a specific project or based on a specific type of products, or casted products or plastic components or stuff like that, and expand from that point. I've also included one example of how we can actually leverage the information or use the information that is contained or stored in the model. So this is based on a QIF model for Quality Information Framework. So from Windchill, we can open or generate a QIF model, QIF model based on a CAD model. And based on that, we can generate a bill of characteristics directly from the model. So we don't need to insert this information manually, which reduces the risk of errors. The bill of characteristics can be exported and used in the first article inspection, and the measurement machine can use this information and report it back to the QIF model, and we can see how well we meet the requirements that is defined inside our MBD models. So this specific process is driven from CapVidia, that can leverage the Creo model. But there is a lot of other similar use cases where we can speed up and use the model information much faster than we could ever do with a 2D drawing. So in this particular case, or in many cases, we can do this process up to 80% faster than with the traditional method based on a drawing. And then, of course, we have the Creo 8 enhancements when it comes to MBD. So one important announcement is that for standalone feature, we can now use the Smart Surface collection in order to generate or gather references. So we can use the seeded boundary capabilities, for example. Which which will give you a more stable references if the model updates, for example. There is some improvements when it comes to the symbol library. This also goes for drawing as well. So it's easier to to place and to find symbols. You can have your own symbols. You can pin your favorites, search for it. So that will make it easier in the end. And when it comes to the Gdt Advisor that is embedded in Creo Parametric, you need to have a special license for it, but it's available for all of you. It now also supports assemblies, so that can be used for example, welded assemblies like the one on the right-hand side. I would also like to mention this. It's not directly related to Creo Parametric 8, but with the latest Creo View release and together with Windshield 12, we can start comparing combined states inside Windshield based on Creo View. So if you open two MBD models in the same session and start a comparing tool, we can see what kind of annotation element that has been modified or hidden or new or deleted and so on. So in a similar way as we compare a drawing, we can compare combined states to have a better traceability of our changes. So my intention for this live presentation is to display how you can follow an MBD process in an efficient way. So it can be good to know that all of these features are available in the out-of-the-box installation of Creo Parametric, so you can start to utilize MBD concept without any additional applications at all. But I think we can speed up the process a little bit by using a couple of additional features that I would like to show you. So what I will do now is to follow this process. I will start from the beginning and prepare my model in order to make it ready for MBD. So if we pretend that this model could have been coming from anywhere, or it's not updated to our latest standard. In order to start this process, that could be valid even in a drawing process, I would like to make sure that we apply the correct parameters on this model. So in order to do that, I basically define some kind of class according to my company standard. And by defining the model class, we have a slave parameter setting for what type of model it is. And this will essentially define what kind of checks that will be run on this model. I can also define the other parameters in a similar way. We have these translation capabilities. So if I'm writing something, it can be translated into multiple other languages. We can also write limitations in the parameters. So in this case, a change or project number can only contain five letters. I'll define some additional parameters as well, and intentionally I will leave the model-based definition checkbox out from this and click OK. All of this information will automatically be applied to my model, and we can then use this information in annotations in our MBD, for example, or in the header of a drawing, or related to other information in the drawing format. So when I have my parameters, I also would want to make sure that we have the combination states needed. And the combination states is gathering view information like orientation, cross sections, and layer states, and so on. So in order to make sure that we follow our company standard in relation to that, I will use this piece of software called Smart Update. The administrator can easily configure it so we run different checks based on what kind of model we are investigating. So from a user perspective, we have access to these tools. In this case, I would like to select what kind of checks I would prefer to run on this one. So in this segment, I have defined my main checks for this. I have one check that is called layer hygiene. We have one that checks the parameter and one that creates the layer states and the combination states needed for this one. So in this case, it doesn't matter how the layer standard is defined by default, for example, or if I don't have any combination states, or if I just have parts of the combination states. By selecting this and update the model, the software Smart Update will generate the information needed, generate the combination states and the layer states and everything. So I have a good position to start from when I'm about to enrich the model with my PMI information. So based on this, we have a couple of combination states. The combination states are using individual layer states, for example. So you can see that the layer that is displayed is different depending on what kind of combination state that I'm using. Also, the orientation can be different. So we can have predefined orientations and cross sections created in this check, essentially. I can also apply some standard annotations on this as well. So in my title block, I would like to have information can be automatically generated based on my previous check, or we can manually assign it by annotating this model. And in the Smart Annotate feature, we have access to different kind of annotations, different kind of symbols and notes. So we can, as an administrator, again define what should be accessible for the end users when they are doing this. So in my particular case, I would like to use this header. I will place it on this combination state by just placing it. Click OK. And simple as that, my combination state is completed with this flat to screen symbol, which contains model information that is generated from the PDS application that I just showed. Another area that I would like to use the Smart Annotate for is for generating properties. So on the Properties tab, I would like to have machine part information from the standard annotation. So here I can decide what kind of information I would like to add. Yellow in this case means that they are required, so it's not optional. But the green one I can decide if I want to use or not. So let's say I would like these two standard annotations on my properties combination state. So I decided what state I want to use them on. I can put the same information on multiple states. And apply. And OK. And as you can see, the Smart Annotate also have the capabilities to display the information in multiple languages as well. So in this case, it's German that is used. If I update this information afterwards, I can update saying that I don't want to have German, I just want to have English in this particular case, and apply it. The symbol is updated automatically. Or if I want to change the actual values that is presented and have something else, that's also easy to change. So that pretty much concludes the first phase of preparing my model. In the next phase, that is enrich. Here I want to add my annotations to make sure that we have the right colors and the nodes and the symbols and so on. And in order to help us with that, we can have the additional applications to speed up the process, or just use standard capabilities that's provided with the standard license of Creo Permacritic. So, like all good TV chefs, I have prepared a model for this that already has some annotations related to the combination states. So I have added the sitemap nodes, which enables me to quickly navigate to another combined states from this view. I've added some geometrical tolerances, datum references, notes. I have another appearance in this state, and so on. So to show you a little bit of what we can do, I would like to add an additional information on the top hole geometry. So based on my GD&T Advisor, which requires a license in order to do this, I can generate a tolerance feature based on this surface. If I press Control, I can also add the other one, and the GD&T Advisor will identify this one as a blind hole. So I accept it. I get some input from the system. So the GD&T Advisor thinks that a position tolerance could be suitable. You need to define the value for it. We need to set the references, and if you want to have the material conditions or not based on this. And the system also automatically identifies references for the whole depth, the whole diameter and the whole depth. So if I accept this, okay, I receive my annotation, but I also receive a warning saying that there's something wrong here. If I want to read more about the warning, I can get help in the associated help section. I can also edit directly from here the dimension or the depth. Or I can go back to the feature itself and edit it from here. So here's the problem, that the depth of this hole is not driven by the right dimension. So I would like to change the D9 dimension to this one instead, D2, and use that as my reference. And I would like to add symmetric tolerance on it and accept. And the same thing for my diameter, but in this case I would like to use table-driven tolerance. So everything is made directly from the GD&T Advisor, and we can always use the advisor tree to make sure that we follow the current standard, basically. When I'm finished, I close this, and I have received annotations that is working the same way as a standalone annotation would do. So I have access to all the information directly from here. Good. So based on this, I make sure that I can see the information. It's readable. In some cases, I might want to change the orientation. So in this case, I would like this one to be standing up instead. So I update and base it on the, I think it's the right orientation plane. And then we have it like this. And I would also prefer to have this one as a section model. So I update my combination state and say that use my cross-section A instead. But flip it, please. Okay, that's good. Excellent. And when I'm finished, I need to make sure to actually update. So I update the combination state with the right orientation and the right states and so on. So I think that's it for enriching the model. So from here we will leave it to Windchill. So what I will do now is basically to check it in. So when the model is checked in, I can go to my workspace again and view it in Windchill. So I've configured my worker to publish an MBD compatible representation of this. So what I basically do is to open that one in Creo, and this is the base for a technical data package. So this one, together with maybe the BOM document, the step file, whatever we need in order to describe it, could be a technical data package. I have this information that needs to be accepted in order to see the content. And then our combination states in Creo is defined on this tab. So here I have the same information that I just created for you. So I have the flat to screen header, we have the sitemap with navigation capabilities, we have all our combined states, we have the color, appearance differences, and so on. And as you know, Creo is included in all Windchill licenses, so you have access to this tool when you have Windchill, and there's also a version of Creo that can be downloaded for free for suppliers, for example, that doesn't have access to Creo. So from PTC's homepage you can download Creo Express. One of the great things is that the symbol management has been enhanced. So we have a different appearance for symbols. You can have your gallery sorted into different categories in which we can search or filter. We can display them in different ways. And from here you basically select the kind of symbol you want to place, and then we have different options for placing this symbol. So I choose the reference I want to use as the primary reference and middle mouse to place it. If we want to customize it, we have it available from here, so we can insert information if that's available, and we can change the inputs and so on. One of the great thing is that all standalone annotations now also have extended access to collect surface references. So what I can do now is to actually add multiple surface based on selection rules. So let's say I want to collect all the surfaces that is adjacent to this reference. I use the rule of a loop surface and based it on the inner edge. So based on these two references, we now collect 11 individual surfaces. And if any of those surfaces is removed, or if I'm update, so we got extra surfaces, they will automatically be included in this selection as well, as long as my two main parents is intact. So that is really good news. We also have the possibility to work with the GD&T Advisor in assembly mode. So that wasn't possible at all in Creo Parametric 7, for example. So the Gdt Advisor gave us the same options in assembly mode. We have our advisory tree, where we can see things that might need to be updated. So here we have something. This reference isn't allowed. Can edit either the tolerance value, or we can actually edit the feature itself. And as we see here, the position tolerance type is not allowed for this specific surface. So we have two recommended tolerances, where flatness is the suggested one. So I'll use that one instead and click OK, and that will solve my issue. Otherwise, we have the same capabilities. We can see what kind of surfaces that is constrained and what is not constrained, and so on. So it's just as powerful as in part mode. Then finally, or the final thing I would like to show you is some updates in the GD&T Advisor as well. So from this tool, we now have better control of what kind of updates that is made on the model side. So if we update something in the model and go back to GD&T Advisor, then we can see the changes now. So from here, we have some unvalidated changes. So this one is related to this tolerance, or geometrical tolerance. It says that we have an invalid attachment for this one. So let's see if we can solve it. I select my annotation, right click, change the reference, and I would like this one to be referenced to a surface instead of an edge. So select the surface, middle mouse to place it, and go back to the GD&T Advisor, refresh the list, and now it's fixed. Then we also have a couple of mismatched features, and this is where we have the news. So for example, if I select the top one, it says that we have some difference in relation to the text. So it states that it should be 4 of this reference, but most likely if I update, it's only using 3 because we have 3 geometrical surfaces to base that on. And it will be removed. Select the next one. We have another example where from selecting my reference, you can see that only 2 of these are highlighted. The third one is not managed. So by updating this one, we make sure that all surfaces is related to this specific tolerance. Here we have a prefix or suffix that is not according to standard, so I update that, and the suffix in this case will be removed or excluded. And then we have 2 references, this one and that one. they doesn't have a diameter symbol in the value at the moment, and they are supposed to have that. So I just update, and it will be automatically inserted into the tolerance. So this is the main enhancements when it comes to model-based definitions. There is a couple of extra that can be discussed separately if you want to, but hopefully you find this helpful when you start your MBD journey. So thank you for your time, and take care.